Welcome back, everyone. In the last session, we have seen basic proportionality theorem. Hope you all were clear with that. In that theorem, we saw that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points. So we drew a line DE parallel to BC, okay, and we proved that AD by DB is equal to AE by EC. Okay, we proved that the other two sides are divided in the same ratio. So always remember this theorem. This will be used in the exercise questions also. Using this theorem, we are going to solve many questions from exercise. So basic proportionality theorem says that if a line is drawn parallel to one side, that line will divide the other two sides in the same ratio, that is AD by DB is equal to AE by EC. This was BPT. In short, we call it as BPT, or this can be called Thales theorem also. So this was given, DE is parallel to BC and AD by DB is equal to AE by EC was RTP. This was our required to prove. Okay. Now, if I see converse of this theorem, what could be converse of BPT? Converse of BPT, as you already know, converse means this given and RTP will interchange, isn't it? So in converse, given will be AD by DB is equal to AE by EC. Okay, AD by DB is equal to AE by EC, and RTP will be required to prove will be what? Required to prove will be DE is parallel to BC. So today we are going to see converse of BPT, which is also very important theorem. So let's continue. Hope you are clear with this. What is converse of BPT? Converse of BPT theorem is here now. You can see if a line divides, you just write it as if a line, okay? If a line divides any two sides of a triangle in the same ratio, okay, then the line is parallel to third side. Okay, so here given is AD by DB is equal to AE by EC. You can take a triangle ABC and a line DE intersecting AB at D and AC at E. So we have taken the figure. How it is intersecting? Such that AD by DB is equal to AE by EC. Now you can see what was our RTP here in the Thales theorem, that is given here. Okay, AD by DB is equal to AE by EC is given, and what was given is our RTP. So they have interchanged. So this is called converse of BPT, basic proportionality theorem. A statement can be given and you will be asked to prove a theorem, or only the name of the theorem will be given. State and prove converse of basic proportionality theorem. Okay, let's see, it's very simple theorem. So we have to prove that DE is parallel to BC. Okay. For that, I'll draw DE dash parallel to BC. Okay, you can see a line here, DE dash, the dotted line. Let that line be parallel to BC. We are going to use indirect method of proving. Okay, we'll consider that DE dash is parallel to BC. It's not looking parallel, but that is our consideration. Okay, we suppose it. So draw DE dash parallel to BC. Since DE dash is parallel to BC, okay, as we have constructed, so according to Thales theorem, okay, I can write AD by DB is equal to AE dash by E dash C. Okay, because Thales theorem says that if a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio. So I said that I suppose that DE dash is parallel to BC. This line is parallel to BC. So I can say AD by DB is equal to AE dash by E dash C by Thales theorem. But already it is given to us that AD by DB is equal to AE by EC. This is also given to us. Yes, this is given to us. AD by DB is equal to AE by EC. and this one we are getting by theorem. So we have got two equations here. You can observe one thing in these two equations, that AD by DB is common in both, isn't it? So I can use Euclid's axiom here. From 1 and 2 I can say things equal to the same thing are equal to one another. So I can say AE dash by E dash C is equal to AE by EC. We get this step from 1 and 2 equations. Is it clear, students? Okay. Now we are going to the next step. From 1 and 2 equations we have got this. I'll add 1 on both the sides of this result which we have got from 1 and 2. So adding 1 on both the sides, because there is no change when you add 1 on both the sides of any equation. So AE dash by E dash C plus 1, AE is equal to AE by EC plus 1. So when you simplify it, you find the LCM. Here the LCM is E dash C, you can see E dash C, and cross multiply, okay, AE dash by E dash C plus 1 by 1, okay. So LCM will be E dash C. Cross multiply it, you will get AE dash plus E dash C in the numerator also. Then similarly here also I will find the LCM. LCM is EC, and cross multiply AE plus EC, okay. Now you can observe one thing here, AE dash plus E dash C is how much? Okay, is it clear till here? Okay, AE dash plus E dash C, E is nothing but AE dash plus E dash C is nothing but AC. So I have written AC. And what is AE plus EC? AE plus EC is also nothing but I can write AC. Okay, so AC and AC gets cancelled here in the numerator. I get 1. Cross multiply, I get EC is equal to E dash C. Thus E and E dash coincide. So do you think EC and E dash C will be equal? Are they looking equal here? EC is shorter, whereas E dash C is bit longer than EC. So this is possible only when E and E dash coincide. Means E and E dash, we supposed a point DE dash, a line DE dash, that is nothing but DE itself. Okay, so E and E dash are not different points, they are same points, and this is possible only when E and E dash coincide. Okay, so finally we say that DE dash is parallel to BC. Therefore DE is only parallel to BC, because E and E dash are, they are not different points, they are nothing but same points. So finally we say that DE is parallel to BC, hence it is proved. So this is one of the most important theorem of this chapter, along with Thales theorem. Practice both the theorems before you forget it. Okay, thank you.